Good morning, students. This is your Dayakar master. In the previous video, that's in the last lecture, we have been discussing about the examples of rings. We have seen the examples of ring of integers, ring of rational numbers, ring of reals, ring of complex numbers, and a special ring, a ring of residue classes, in which I have chosen Z5. What is Z5? Z5 consists of all residues of 5, that means remainders of 5 on dividing with 5. That is Z5. Z5 consists of 0, 1, 2, 3, 4. And the binary operations are special addition and special multiplication. What those special addition and special multiplication are? Addition modulo 5. Since we have chosen Z5, we have to choose addition modulo 5 and multiplication modulo 5. Z5 with respect to addition modulo 5 and multiplication modulo 5 forms a ring. With respect to addition modulo 5, we have written the composition table with respect to addition modulo 5 and with respect to multiplication modulo 5 also, and we have verified all the axioms that are required. With respect to addition modulo 5, that should be an abelian group: closure law, associative law, existence of identity, existence of inverse, and commutative law. And with respect to multiplication modulo 5, we should see that is a semigroup or not. For that, we need two axioms: closure law and associative law. We have verified successfully, and distributive laws will follow. Therefore, Z5 with respect to addition modulo 5, multiplication modulo 5 is a ring which is said to be a ring of residue classes. While discussing about that addition modulo 5 and multiplication modulo 5, we have simply considered the associative laws of addition modulo 5 and multiplication modulo 5. Let us discuss about those associative law. We considered associative law will follow with respect to addition modulo and with respect to multiplication modulo. How? Let us verify is associative law is verified or satisfied with respect to addition modulo and with respect to multiplication modulo, and the commutative laws with respect to addition modulo and multiplication modulo. Let us see in this lecture. See this. Addition modulo is associative. Similarly, multiplication modulo is also associative. First, let us discuss about this. Addition modulo is associative. A, B, C are any three integers. A, B, C are any three integers. This m is least positive integer. So, A addition modulo m, B addition modulo mc should be equal to A addition modulo m, B addition modulo mc. Associative law. A plus x plus y plus z is equal to x plus y plus z. That is associative law, but this is special addition modulo m. Okay. Let us pick up a small example. In place of A, B, C, I have chosen 2, 3 and 4. In place of m, positive integer m, I have chosen 5. So, 2, 3, 4 are integers, and m is 5 is the least positive integer, and the operation is addition modulo 5. Let us see. 2 addition modulo 5, 3 addition modulo 5, 4. First, we should solve the thing that is in brackets. 3 addition modulo 5, 4. What is 3 addition modulo 5, 4? Already, as we know already, 3 addition modulo 5, 4 is add 3 and 4. 3 plus 4. What is 3 plus 4? 3 plus 4 is 7. Divide 7 with 5. This is 7. Dividing 7 with 5, 5 ones are 5, the remainder is 2, which is that. The resultant of 3 addition modulo 5, 4 is 3 plus 4, 7. Divide 7 with this 5. Pick up the remainder is 2. So, 3 addition modulo 5, 4 is 2. The thing is solved. 3 addition modulo 5 4, result is 2. Now 2 addition modulo 5 2, 2 plus 2 4. Anything that is less than 5 is the same. 2 plus 2 4, divide 4 with 5, 5 zeros 0 4, and we are dividing with 5 zeros 0 times, and 4 is the remainder. This is the resultant. So add 2 and 2, divide that 4 with 5, it will go 0 times and the remainder is 4. So finally 2 addition modulo 5, 3 addition modulo 5 4 is 4. What about this one? First we add 2 and 3 and finally with 4. 2 plus 3, 2 addition modulo 5 plus 3. For that what we have to do? Add 2 and 3. Add 2 and 3. What is that? 5. Divide 5 with 5. Remainder is 5. Divide 5 with 5. 5 ones are 5. The remainder is 0. Therefore 2 addition modulo 5 3 is 0. Remainder is 0. 0 addition modulo 5 4. 0 plus 4 4. Divide 4 with 5. The remainder is 4. So 2 addition modulo 5 3 addition modulo 5 4 is 2 addition modulo 5 3 addition modulo 5 4. Both are same. A addition modulo m, B addition modulo mc is A addition modulo mb plus addition modulo mc. So addition modulo is associative. This is in general, and we have picked up particular examples 2 3 4 and addition modulo 5. Therefore clearly addition modulo is associative. Is addition modulo commutative? Let's verify. Addition modulo is commutative. I had declared addition modulo is commutative. A addition modulo mb should be equal to A addition modulo B addition modulo ma. Let us say in place of ab we shall choose 4 and 6, and in place of m5 4 addition modulo 5 6. What is 4 addition modulo 5 6? First add 4 and 6. What is 4 plus 6? 10. Divide 10 with 5. Since this is addition modulo 5, divide with 5. 5 2s are 10 and remainder is 0. So this is 0. The value of 4 addition modulo 5 6 is 0. What about 6 addition modulo 5 4? This is 4 addition modulo 5 6 and this is 6 addition modulo 5 4. Anyhow, we have to add 6 and 4. Here 4 plus 6, here 6 plus 4. The result is same. 6 plus 4 10. Dividing with 5 we get the result, the remainder as 0. So both are equal. The remainders here are equal. The sum is equal. Therefore A addition modulo mb is clearly equal to B addition modulo ma. Therefore addition modulo m is commutative. Addition modulo m is associative and addition modulo m is commutative also. In every case we are choosing positive integers. Simply we are choosing positive integers. If we choose negative integer, here a, b, c are any integers. Any integers means there may be positive integers or negative integers. If you take 0, that's also okay. If you pick up negative integers, see minus 4, minus 7. I have chosen 2 negative integers, minus 4, minus 7. This should be a positive integer. Addition modulo m should be a positive integer always. So this is plus 5 only. Addition modulo 5. Minus 4, minus 7. Add up minus 4 and minus 7. What is the sum? Minus 4 minus 7 is minus 11. Divide with this modulo 5. 5. Here the dividend is minus 11. How many times it will go? If you take 2 minus 2, that will be minus 10. Minus 10 is greater than minus 11. Therefore go for the value which is less than minus 11, that is minus 15. 5 into minus 3, 5 minus 3 times is minus 15. Minus 11 minus 15, minus 11 minus of minus 15, that is 4. Remainder is 4. So what is the value of addition modulo minus 4? Minus 4 addition modulo 5 minus 7. The value of minus 4, addition modulo 5 minus 7 is 4. Minus 11 dividing with 5, minus 3 times it will go, the remainder is 4. So, in addition modulo or multiplication modulo, the ABC are any integers, strictly integers, any integers. This modulo m should be a positive integer. So, addition modulo is associative, addition modulo is commutative. We have agreed. Let us see multiplication modulo is associative or not, and commutative multiplication modulo is commutative or not. First, let us see multiplication modulo is associative or not. A multiplication m brackets b multiplication modulo mc should be equal to a multiplication modulo mb multiplication modulo mc. A x into yz is equal to xy into z. I have chosen 2, 5, 4. 2, 5, 4. The least positive integer is 3. So, 2 multiplication modulo 3 in the brackets, 5 multiplication modulo 3, 4. So, 5 into 4. What is 5 into 4? First we have to solve the thing that is in brackets. 5 into 4. What is 5 into 4? 20. Here the modulo is 3. Modulo 3. Multiplication modulo 3. 20. Divide 20 with 3. 3 6s 18, remainder is 2. So, the value of 5 multiplication modulo 3 4 is 2. The value of 5 multiplication modulo 4 3 is 2. Why? Because 20 dividing 20 with 3, it will go 6 times, 18, remainder is 2. Now 2 into 2, 4. 2 into 2 is 4, and remainder on dividing 2 into 2 with 3, 4. 3 ones are 3, remainder is 1. So, finally, the result is 1. Here also the result is 1. Let us see this one, right hand side. 2 multiplication modulo 3, 5. 2 multiplication modulo 3, 5. 2 5s are 10. Divide 10 with 3. Since this is multiplication modulo 3, divide 10, 2 5s are 10. Divide with 3, 3 3s it will go 9. Remainder is 1. So, 2 multiplication modulo 5, 3 is 1. And on the right hand side, it is 4. 1 multiplication modulo 3. 1 into 4 is 4. Divide 4 with 3, we get 1. 4. 4 and divide with 3. 3 ones are 3 and remainder is 4. Here both are same. Left hand side is 1, right hand side is also 1. Therefore, left hand side is equal to right hand side. That means A into BC is equal to AB into C. Multiplication modulo is also associative. Finally, let us go for multiplication modulo is commutative or not. That means A into A multiplication modulo MB is this one equal to A B multiplication modulo MA. A into B is equal to B into A. Let us pick up, in place of A and B I have chosen 4 and 6. In place of M I have taken 5. 4 multiplication modulo 5, 6. 4 6s are, what is that? 24. 6 4s are 24. So, divide 24 with this multiplication modulo 5. 5 4s are 20, remainder is 4. 6 4s are 24 or 4 6s are 24. Therefore, dividing 24 with 5, the remainder is same here. Both are same. Why? Because 4 into 6 or 6 into 4. Being integers, the ring of integers multiplication in the with respect to multiplication axiom, the ring of A into B is equal to B into A in the ring of integers. Therefore, 4 into 6 is equal to 6 into 4. Both are 24. The remainders here are 4. So, in the similar fashion, I have just changed this. In place of 6, I have chosen minus 6. Why? Because ABC are any integers. The multiplication or addition of that m is a positive integer. I have chosen, for another example, I have chosen 4 into minus 6. If it is minus 6, 4 into minus 6, minus 24. Divide with 5. minus 25 is less than minus 24. Minus 20 is greater. That is why I have taken 5 times. 5 into minus 5 times. 5 into minus 5 is minus 25, which is less than minus 24. The remainder is 1. Therefore, 4 multiplication modulo 5 minus 6 is 1. This is equal to minus 6 multiplication modulo 5, 4. Both are same. Okay. So, what I would like to say is, addition modulo is associative, addition modulo is commutative, multiplication modulo is also associative, multiplication modulo is commutative, and addition modulo is distributive with respect to multiplication modulo. Addition modulo is distributive with respect to multiplication modulo. What does it mean? That is, A multiplication modulo MB multiplication modulo MC. Addition modulo is distributive with respect to multiplication modulo. A multiplication modulo MB multiplication modulo MC is equal to A addition modulo A into C kada. A multiplication modulo MC plus A multiplication modulo B multiplication modulo MC, right? A into C, B into C. Here addition modulo M. We say addition modulo M is distributive with respect to multiplication modulo M. A addition modulo MB multiplication modulo MC is A multiplication modulo MC plus addition modulo M, B multiplication modulo MC. Simply this is x plus y into z is equal to xz plus yz. What this is? Right distributive law, RDL, right distributive laws. Similarly, we can have left distributive law. So, addition modulo M is distributive with respect to multiplication modulo M. So, addition modulo is associative, commutative, multiplication modulo is associative, multiplication modulo is commutative, and addition modulo is distributive with respect to multiplication modulo. So, left distributive law, right distributive law, both will satisfy. Thus, the distributive laws hold in case of residue classes. So, Z5 addition modulo, in this particular example we have chosen Z5 addition modulo 5 multiplication modulo 5. This is clearly ring of residue classes, We may choose 7, Z7 like this, Z11. This is a ring, In general, ZM addition modulo M multiplication modulo M. These are the binary operations. If this is M, you have to choose addition modulo M multiplication modulo M. This is 11, we have to choose addition modulo 11 multiplication modulo 11. This is 7, we have to choose addition modulo 7 multiplication modulo 7. Otherwise, they are not rings. If you choose like this only, the algebra structures will become rings. If not, they cannot be the rings. So, Zm means, what is Zm here in general? 0, 1, 2, 3, 4 up to m minus 2 and m minus 1. Since it is m up to m minus 1, you will get from 0 to m minus 1. So, Zm addition modulo M multiplication modulo M is always a ring which is said to be a ring of residue classes. Residue classes. So this is a special example of ring, which is a ring of residue classes. Next we go for another example, that is a ring of matrices. We can see in the next video. Follow up.